In this lesson we are going to study about Euclid's division lemma. The objectives of this lesson are: we will understand how to use what is Euclid's division lemma, and we will use Euclid's division lemma EDL in finding the HCF, highest common factor, in finding the HCF of two positive integers. So we will understand what is EDL, and we will use EDL in finding the HCF of two positive integers. We all have learned about long division. Let's take 5 divided by 3. We know how to do this. 1 times is 3 and the remainder is 2. So 5 is equal to 3 times 1 plus 2. Let us take in general 5 is A and 3 is B, and 1 is Q and 2 the remainder is R. So we can say that whenever A is divided by B, A is always equal to B times Q plus R. And note that Q and R will always be unique, and R will be greater than or equal to 0, and R will always be less than B. So in other words, R will be between 0 and B. This A is equal to B times Q plus R is called Euclid's division lemma. We can state this theorem formally, that given positive integers A and B, there exist unique integers Q and R satisfying A is equal to BQ plus R, where R is between 0 and B, R is less than B, and R is greater than or equal to 0. We can use, or we can find, the highest common factors of two positive integers using Euclid's division lemma. We will see how to find this out. What do we have learnt about finding highest common factors. Let's take, we find the highest common factors of 8 and 4. What do you mean by factors? All those numbers which divide 4. Let's take, so factors of 4 are 1, 2 and 4, and factors of 8, meaning all those numbers which can divide 8, are 1, 2, 4 and 8. Now what are the common factors of 4 and 8? 1, 2, 4. And what is the greatest common factor? It is 4. So the highest common factor of 8 and 4 is 4. So we know how to find the highest common factors. Now let's find out the highest common factors using Euclid's division lemma. So let us find the HCF of 455 and 42 using Euclid's division lemma. Since 455 is greater than 42, we start our division process. 455 divided by 42. So it will be 455 is equal to 42, goes in 455 10 times, and the remainder is 35. We continue the process. 42 divided by 35, and 35 goes in 42 once, leaving a remainder of 7, We continue the process. 35 divided by 7. 7 goes in 35 5 times, and the remainder is 0. Now since the remainder is 0, we stop. We cannot proceed further. And 7 is the highest common factor of 455 and 42. So this is how we can use Euclid's division lemma in finding the highest common factor of two positive integers. Let's try one more. Use Euclid's division lemma to find the highest common factor of 4052 and 12,576. Now since 12,576 is the larger number, we start the division process. 12,576 divided by 4,052. So how many times will 4,052 divide 12,576? That is going to be equal to 4,052 times 3, and leaving a remainder of 420. We continue the process. 4,052 divided by 420. 4,052 will be equal to 420, which will go in 4,052 how many times? 9 times, leaving a remainder of 272. We continue the process. 420 divided by 272, and that's going to be 272 times 1, leaving a remainder of 148. We continue the process again. 272 divided by 148. So 148 times 1, leave and remaining 124. Continue the process. 148 is equal to 124 times 2 times 1, plus 24. Continue the process. 124 divided by 24, which will be 24 times 5, plus leaving a remainder of 4. And divide 24 by 4, which is 4 times 6, and leaving a remainder of 0. Now since we have landed with the remainder 0, our highest common factor is 4. So the highest common factor of 12,576 and 4,052 is 4. Let's try this. Use Euclid's division lemma to find the HCF of 135 and 225. Now since 225 is larger than 135, we divide 235 by 135. So 225 divided by 135. So 135 times 1, and the remainder is 90. Continue the process. 90 times 1, and the remainder is 45. And 90 divided by 45. So 45 times 2 is 90, and the remainder is 0. So the HCF is 45. So the HCF of 225 and 135 is 45. Let's try this. Find the HCF of 196 and 38,220. So 38,220 divided by 196. So 196 times 995, and the remainder is 0. So the HCF is 196. Let's try this. Find the HCF of 867 and 255. So 867 divided by 255. So 255 times 3, and the remainder is 102. Continue the process. 255 divided by 102. So that's going to be 102 times 2, leaving a remainder of 51. And 102 is equal to 51 times 2 plus 0. So the HCF is 51. Let's try this problem. A sweet seller has 420 Kaju Barfis and 130 Badam Barfis. She wants to stack them in such a way that each stack has the same number and they take up the least area of the tray. What is the maximum number of barfis that can be placed in each stack for this purpose? So we need to, in other words, find out what is the HCF of 420 and 130. So let's find the HCF of 420 and 130. So 420 divided by 130. So that's going to be 130 times 3, leaving a remainder of 30. Continue the process. 30 times 4, leaving a remainder of 10. Divide 30 by 10, 10 times 3, and the remainder is 0. So the HCF is 10. So she needs to stack. She needs to prepare stacks of 10 barfis. Let's try this. An army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? So in other words, find the HCF of 616 and 32. So 32 times 19, and the remainder is 8. So 32 divided by 8. So 8 times 4 is 32, and the remainder is 0. So they will march in columns of 8. So they'll march in 8 columns. So we learned how to use Euclid's division lemma in finding the HCF, and we understood what Euclid's division lemma is. If you need further contacts, for further information, you can contact me at askarkhanacademy@gmail.com. My name is Askar Ali Khan. Thank you for watching this video.